Good evening. So tonight, this is the 7th in the On JavaScript series. In the previous episodes, we've been talking about ECMAScript 3, which is the version of the standard that's been in the field for the last decade. Tonight, we're looking at ECMAScript 5, the new parts. So first, to put this in context, we're talking about a standard and the effect of the standard on the world. Any change to a standard is an act of violence. It's like putting a knife into a person. Now, is it ever right to put a knife into a person? Yeah, sometimes it is. Surgeons do that. So a surgeon will make a determination that the benefits that could come from cutting someone open and fiddling with the things inside of them is worth the pain and the expense and the inconvenience and the risk of infection and complication. Working with a standard is not quite so dramatic, but it's a similar set of trade-offs. For example, when you make a new standard, it means now there are two standards, and that introduces problems that didn't exist when there was one standard. That's particularly a problem in the web because we're going to have old programs or old sites and new browsers, and we'll expect those to work, and we'll have new programs and old browsers, and we'll expect that to work. So there are combinations that are really difficult to manage since we expect to have compatibility going backward and forward without breaking anything. That turns out to be really hard, and it's especially hard in the web. And that's going to color a lot of what I'm going to talk about tonight. So the reason this is a good time to talk about ECMAScript 5th edition is that we are beginning to see complete implementations coming out and are now being seen in the world's best web browsers. So this is a good time to look at it. A little bit of history. So the 3rd edition, which is what we have been using, has been in the field since 1999. In 2009, the ECMA General Assembly approved what we're calling ES5, the 5th edition, which actually is two standards. It is the standard for the default language, and it's the standard for a new strict mode language. They're both described in the new standards document. So which of those languages should you use? I'm recommending that in the short term, you be working in the intersection of ES3 and ES5 strict. And in the long term, you should be working with ES5 strict. ES5 strict is going to be the future of ECMAScript. Future editions will be based on that. There might be temptations to be using ES5 default. My advice is to resist those temptations. Some people will be disappointed to learn that what we were trying to do with ES5 is to make a better JavaScript. There were some people who were hoping that we would either kill it or that we would transform it into a completely different language, turn it into Java or something that's more conventional. We didn't do that. Instead, we improved the language to make it better at what it is and improving its operations, but not substantially changing it. So there are no big changes to the language. Instead, we made lots of little changes. We made the standard conform better to reality. There were some places where none of the browsers implemented what the standard said, and all the browsers were right. So in those cases, we corrected the standard to match reality. There are some cases where the browsers did not disagree, and we had a 3 out of 4 rule. So if 3 of the browsers did one thing and Internet Explorer did something else, then we would conform the standard to what the majority was doing. And Microsoft was very good at working with us to do that. It's difficult to change standards in the web because of the likelihood of breaking things. So any place where we found that the browsers were in general disagreement, we took that as license to make changes. So in some cases, we discovered or found ways of putting good behavior into the language. In places where we were hoping, at least with respect to the web, people were not using the language. As a result of all of these things, we think that interoperability will be improved. Now, it turns out interoperability with JavaScript is already really good, but it will get even better. The main place where it gets better is in the edge cases. And I recommend that you not be at the edge anyway, because that's the source of pain and misery. But if stay to the middle of the language, it's already very interoperable, but it gets even better. So if you program pretty well, this class of improvements, of spec improvements and consolidation, shouldn't have any impact on you. Your code should continue to work fine. So the goals for ES5 were, number one, most important, the prime directive was don't break the web. We didn't keep this, or we don't know that we didn't keep it, but I expect that we will break at least a little bit of the web. And that's just the nature of the web, that if you make any changes for the better, there are people who are dependent on it being worse, and they will break. But we tried really, really hard to minimize the amount of breakage we're going to cause. We're improving the language for the users of the language and not for people who do not use the language. So we're not trying to make JavaScript more like Java now. We're trying to make JavaScript better at being JavaScript, and I think we succeeded at that. We gave a lot of attention to improving third-party security so that we can do mashups, and I'll talk a lot more about that later. We did not set out as a goal to protect stupid people from themselves. That's just too hard. So stupid people will do stupid things, and we're not doing anything to prevent it. And we've added some powerful new capabilities to the language which will allow people to do even more stupid things. That's just the way it works. And then finally, we adopted as a rule no new syntax. The reason for that is that new syntax on old browsers is a syntax error. And so we're trying to figure out a way to provide as much value to people using the new language even on the old browsers as possible. So if there's a lot of new syntax, all of that's going to do is frustrate you, because it means that there are powerful new things that the language can do, but you cannot use as long as IE6 still exists, and it's going to be around for a long time. So that doesn't actually do you any good. So we tried as much as possible to add powerful new capabilities to the language without using syntax to accomplish that. Now, despite that, we actually did add some new syntax. And I recommend that you not use it, because it will cause your programs to fail hard on all versions of IE before 9. But it's good stuff, so let me show you what you're going to get that you can't use. This is mostly in the line of corrections to the grammar, not new constructs. So first off, you now get trailing commas in literals. So you can have an object literal with a trailing comma. Some people get confused about how commas work. They think they should be delimiters rather than separators. Now you can think about them either way. So ES5 will ignore that trailing comma. It turns out trailing commas have always been legal in arrays, but their interpretation differed. On most of the browsers, a trailing comma is ignored, but on IE, it counts as an extra component. So the length of that array literal on most of the browsers is 2. On IE, it was 3. And so that's going to clearly cause interoperability problems. In ES5, it's going to be 2 everywhere. So we corrected that. We fixed the reserved word policy with respect to properties. This used to give you lots and lots of syntax errors, no errors anymore. So it used to be that reserved words had to be quoted in object literals, and you had to use subscript notation with quoted strings instead of the dot notation. Now you can use the dot notation proudly everywhere. All legal identifiers are permitted there. Again, you can't use this as long as there's IE6, but someday your children will be able to use this. We have getters and setters in the language now. So getters and setters define special properties. We call them accessor properties, which instead of setting and retrieving a value, will call functions. And those functions can do whatever you want them to do. Generally, they'll set and obtain values. So here I've got a temperature constructor, and it has two properties, Celsius and Fahrenheit, and you can set one and retrieve values from the other, and you'll always get the stuff. So it does conversions for you automatically. You can do very clean, very elegant, very expressive APIs using getters and setters. You also can do horrendous nightmare stuff. This is one of the places where you can very easily get stupid. I expect we're going to see a lot of clever kids getting online saying, look at the stupid things I did with get and set, but nobody thought we could do that. Well, actually, we know you can do that. We're just hoping that you don't. The problem with get and set is it breaks one of the invariants of the language. It used to be that when you're accessing an object, either retrieving a value from a property or setting a value in a property, you can be confident that nothing else in your world is going to change while you're doing that. That's no longer the case. So now fetching a value from an object can have side effects that affect things all over the system. That makes the language a lot harder to reason about. Now, you don't have to do that kind of stuff, and we're hoping that people won't, but you can really uglify your world pretty significantly with this feature. We've got multi-line string literals in the language now. We copied a number of other languages that do this. I think this is a bad part. It wouldn't be ECMAScript if we weren't adding at least one new bad part to the language, and I think this is it. I don't like these for a couple of reasons. One is it screws up indentation because the continuation line has to start at the left column, and so it's just really ugly to read. But the other problem is that there's a syntax problem, right? So the first line is okay, and the second one's got an error. Can anyone spot the error in the second one, in the second statement? What? Yeah, there's a space there. See, there's a space at the end of the line. It's obvious once it's pointed out. But my philosophy is you don't want to be using constructs that are difficult to distinguish from common errors, and this is one of them. The alternative is just to have a lot of strings and plus them together. A smart compiler will clean that up for you without any overhead. I think that's the better way to do it. I don't think you get much value out of this. These things are now constants. In ES3, strangely, they were variables, which means you can go to the global undefined variable and set it to 5 and cause all the programs to break. We fixed that in ES5. They're constants now, so if you change them, that won't happen. Undefined stays undefined. That's a good thing. We fixed parseInt. So parseInt of the string 08 now yields 8 and not 0. So it means on ES5, it's no longer necessary to provide the radix parameter. So that's nice. Now, as long as ES3 is still in the world, as long as there's still IE6, you still have to use the the radix parameter because you might be running there someday. Regular expression literals now produce a value every time they're evaluated. So that corrects a bug in which you would only have one instance of the regular expression object, which could cause problems if you had multiple uses of that using exec. We cleaned up a problem where you can change object and array to your own functions. And the way the ES3 spec was written, it would always use your version of those. And there are security problems, obvious security problems that came from that. So we corrected that language in the spec so that anytime you're creating new objects or arrays, it is as if you were using the original constructors. So you'll always get the right stuff. So that makes the language a little bit more resilient. We added a lot of new methods to the language. It turns out adding new methods is a powerful way of adding functionality without having breaking syntax, because no new syntax is required for having new methods. And for a lot of the new methods that we're defining, it's possible to implement them in JavaScript, which means that an AJAX library can add these new methods to the primordial objects, which allows ES3 implementations to act exactly like ES5 implementations, except maybe a lot slower. So that's a benefit which helps us have compatibility going backwards and forwards. And we don't feel bad about IE6 going a lot slower than, say, IE9, because we really want to encourage people to move forward. So the first stuff you get is JSON. JSON is now built into the language. It is standard equipment in JavaScript, no tricks, it's there. And it uses the JSON2.js interface. So if you're using JSON2.js, you're already set. No changes to your programs. When you get onto ES5, they'll just run faster. JSON2 will get out of the way and allow the native interfaces to work. By the way, stringify is my fault. I thought of that. I didn't want to call it toString because it's a transformer. It's not a deserializer. But a lot of people don't like that name, but that's what it is. We're stuck with that. My fault, sorry. We've got a lot of other functions, and if you're going to define these functions in your code, I highly recommend that you first test to see if the function is already defined, and if it is, then don't do it. The technique that I've used for deciding that has changed over the years. Originally, I thought just doing a falsy test was sufficient. That turns out not to be the case. Then I was doing a type of against a function. That turns out to not work either, that MooTools and some of the other Ajax libraries will screw you up. So now I call has own property to decide if I'm going to do that setting. So we now have the function bind method, which is something that's standard in a number of the Ajax libraries. It's now built into the language. It's a currying function which takes a function and returns a function which binds this and possibly some of the parameters that you passed to it. It allows you to take methods and use them in places we expect a callback or a simple function. So this is a very handy thing to have, and it's now standard equipment. String trim is now standard equipment in the language. Yes, you may applause. Thank you. So trim will take a string and remove the excess white space from the ends, which is something we've always needed, and now we've got it. We've got a large set of array methods. These were worked out originally by Mozilla for Firefox, and they're really good. The thing they all have in common is they take an array and a function, and they call that function for each element in the array. And they all do something slightly different with that configuration. We took the API as Mozilla specified it. And it was a bit of a problem because there are a couple of things that I think they got wrong in their API. But it was well established in the field, and so we felt that if we repaired the API, we'd probably break stuff, and we didn't want to do that, so we took it as is. So my complaints with this are, first, the optional this p argument. I think it's just unnecessary, so I think it clutters the API. Much more significant is when it calls your function, it passes that function the current value, which is the right thing to do. It passes it the subscript, which is all right, but it also passes the array itself. And I think that's giving too much authority to that function. It didn't need that information, or if it did need it, you could provide it to it. I think it was a mistake to have that delivered to the functions implicitly. But we're stuck with that. So despite that, these are really good functions. So the every function is sort of an AND function where we'll call a function on each element of the array, and as long as they return falsy values, it keeps going. Was it falsy or is it truthy? As long as they're true, it keeps going. We've got filter, which I think is a more useful function, where it's called on each element and returns true or false, and for all the ones where it returns true, it adds them to a new array. So it's a very nice way of selecting stuff out of an array. We have for each, which simply calls a function for each element. This is brilliant. I use it a lot. There's some people who say, don't use this, keep using for loops because it's faster. I think that's terrible advice. The speed difference is not significant, and the benefit in the way you can express things in code is really profound. So I'd highly encourage use of these functions. Index of is like string index of, in that you can find an element within an array based on its value. Last index of does it from the other direction. Map is a useful function. It's like for each, except for each of the values that came back, it puts them into an array for you. So that's a nice way of doing transformations on the elements of an array. We have a reduce array, which calls a function for each value and takes that return value from each one and passes it as an argument into the next one. You can use this for doing sums, products, mins, and maxes. It's a very useful thing. Reduce right does the same thing from the other end of the array, not nearly as useful. And sum, which is the inverse of every. So this is the OR function, which keeps going until it finds a false value. Date.now. So it used to be if you wanted to get the current time in milliseconds, you had to create a date object and then extract its value out, and that can take some time. And that's a problem because usually when you're using dates in this way, you're measuring time. You're trying to see how long your program is taking to run, and so that gets in the way. So date.now is standard equipment, where it'll just return the thing very quickly. We now have support for ISO dates in JavaScript. So ISO dates are an international standard for formatting dates and times. It's probably the best format we have, at least for data processing applications, and it's now built into JavaScript. So using toIsoString, you can get one of those forms, and then new date and date.parse will take that as input. One problem in ES3 was that it underspecified how date parsing worked. So pretty much left that up to the implementers. It was proprietary. So there was no guaranteed standard that would work for date formats in all browsers. We now have a format that is guaranteed to work. So the browsers will first try to use the ISO format, and if that fails, they will then try to use their proprietary formats. We have object.keys. Now this probably should have been object.prototype.keys, but we were afraid that if we put it on object.prototype, it was very likely it was going to collide with other applications, and we didn't want to do that. So we put it on on the object, which was a little bit safer. We found there were still some collisions, like prototype likes to mess with this stuff, but that's okay. So they'll have to fix it. So what keys does is you give it an object and it returns an array containing all of the own enumerable keys of that object. And that turns out to be a really powerful thing. One thing it means is you don't have to use for-in anymore, which is really nice. So one of the problems with for-in was there was no guarantee as to what order the keys would come out. But getting the keys all in one array, that means you can then call sort. So you can say object.keys.sort.forEach and get a nice thing where they all come out in the order that you like. So, and that level of programming is now trivial to do. It used to be really hard. We've got object.create, which makes a new object which inherits from an old object. Really powerful. This is the key operator for prototypal inheritance. It used to be hidden in the language. Now it is first class in the language. So it's very straightforward to make these things. One other nice thing that you can't see from this, because you only get this in ES5, you can't simulate this in ES3, is you can call object.create passing it null as the prototype. And if you do that, then you get an object that inherits nothing. And that turns out to be a really powerful thing. We'll talk more about that later. It is finally possible to figure out if a value is an array in the language. This was hidden for a long, long time, but it's now first class in language in array.isArray. You pass out a value, it returns true if it actually is an array. We have a powerful new meta-object API in the language. which gives you control over the attributes of the properties of objects. Okay, you know what objects are. Objects have properties. We sometimes call them members or methods or elements, but they're all properties. Properties have attributes. And this goes all the way back from the original language, but you could never see them. You could sort of detect them sometimes, but mostly they were in a place where they were invisible to you. So they had names in the original standard like don't enum and read only and don't delete. And when those attributes were turned on, then they can have that control over a property. So you could set a property to be read only. That meant that nobody could modify it. Or you could set a property to be don't enum, which means it would not show up in the for-in iteration, which would have been a really good thing if they had exposed it to you. But they didn't. They specified it as a necessary thing for implementers to provide to the executing environment, but they didn't expose it to the users of the language. So there was this frustration there where you wanted to set don't enum on your property so they didn't screw up your for-in loops, but you couldn't. But now you can. So we finally now have an API which gives you access to the stuff, and it turned out really, really nicely. So before I show you the API, I need to explain that there are two kinds of properties now. There are data properties, which are the kind of properties that you're used to, that we've always had. They have a value that you can set or retrieve. And there are accessor properties. Accessor properties are things that have get and set on them, the getters and setters. So they don't store a value, they just associate two functions with the property. So there are now 6 attributes in the language. And the first 4 can be assigned to data properties, and the last 4 can be assigned to accessor properties. So data property can have a value, it can be writable, it can be enumerable, it can be configurable. Accessor properties can be enumerable, configurable, and they have a set function and or a get function. Now for the Boolean values, you can set them to true or false. Once they get set to false, they can never be turned back to true. So if you want something to be read only, you set writable to false, and nobody can turn that back on again. So that allows you to have some integrity in your objects now. So writable means that you can't modify it, can't modify the value. Enumerable means it does not show up in for-in or in object.keys. And configurable means that you can't delete it and you can't change it to another kind of property. So let me show you an example of how we can set up a data property. So you see 2 statements here. They both do exactly the same thing. The first one is the way we would do it on ES3, and it still works in ES5, but in ES5 we've got more options. Now you might look at that and you go, holy cow, how is this an improvement? I mean, this is a whole lot of code to do what we used to do with very little code. The interesting thing here is we've got some options now that we didn't have before. For example, I don't have to inherit from object.prototype. I can change that object.prototype to be a different object, and we can inherit from somewhere else. And I now have control over those attributes. So I'm using a function here called object.defineProperty. It takes an object that we're going to inherit from, or that we're going to modify, the name of a property, and a descriptor object. A descriptor object is just an ordinary object, but its keys are the same as the names of the attributes that we want to set. So here I now have control, finally, over writable, enumerable, and configurable. The default for object literals is to set them all to false. The default for this form is to set them all to true. This one wants to set them all to false. So you have to explicitly set them to true if you want them to be true. So we finally have control over those bits now, and that's a powerful thing. We have a similar form for doing accessor properties. So it's the same thing, except now we give it a descriptor object that's got get and set in it, which will be functions that will do useful things. In this case, I'm setting enumerable to be true, so it'll show up in my for-in statement, but I did not set configurable to be true. So that means that they will not be able to delete this guy or change him to be to have different getters and setters or to have a different value. So this then is the new meta object API. We've got define property, which you just saw. We also have define properties, plural, which takes an object of descriptors, so you can set a lot of these at once. So the object of descriptors has a key for each property that we want to set, and a descriptor which is a separate object which describes what it's going to do. We also have functions which will retrieve these values for you. So we've got getOwnProperty descriptor. You give it an object and a key, and it gives you back one of these objects which describes the attributes. There's also getOwnProperty names, which is like keys, except it returns all of the owned properties, even the ones that are not enumerable. And we also have a getPrototypeOf function. I'm recommending that you not use these functions because there are some security implications to these, and secure frameworks may ban their use. You might wonder, well, why did we add things to the language that you don't get to use? We added these specifically for Caja to allow it to inspect the system in order to make it easier for it to lock the system down. So it's likely that what Caja will do with things like getPrototypeOf is it'll use it for its own use and then delete it from the system so that you can't get at it. We also have control now over extensibility. So there's an attribute in objects which controls whether or not you can add new members, new properties to that object. The key method here is object.preventExtensions. This sets that bit, and once you've set that bit, you cannot clear it again. So again, that will lock an object so that you cannot add new properties. There are two other methods. One is object.seal, which does the same thing, except it also goes through all the properties in that object and turns off their configurable bits. And there's also object.freeze, which does the same thing as seal, except it also goes and turns off all the writable bits. So you can freeze an object now, and that makes it immutable. It means that you cannot modify it or any of its properties. If any of its properties are mutable themselves, then you can still change them, but the top level of the thing is frozen. It's not a deep freeze, it's a shallow freeze. We also have methods which will return true or false on whether or not any of these things have happened to the object. So is extensible will be true if preventExtensions has been called on it. One of the things that's repaired by the new ES5 features is we've got a large class of unintended inheritance problems. So this is one of them. I want to count all of the unique words in a text. So I create a word count object which will contain all of the words. The keys will be the words themselves, and the values will be the number of occurrences we see. Then we'll pass our text to split and split it on white space and punctuation. And then we'll call for each on the array that split returns, passing in a function which will go through and count all of the words that it finds. The problem with this implementation is that if one of the words in our text is constructor, then it will fail in a really unexpected way. And that's because constructor is a word that's inherited by all objects. And most of the time we don't notice that, but sometimes, like in applications like this, it bites us. So fortunately, ES5 now provides us several alternatives for getting around that problem. One of them is that we could use object.createNull to create our word count object. That says that we want this object to inherit nothing. That means it will not have a constructor property, it will not have a toString property, it will not have a hasOwn property. And that means that we don't have to worry about these collisions. It's guaranteed to be collision free. For other classes of problems, we can set the enumerable attribute to false when we're adding methods or other values to the prototypes. That will also prevent accidental inheritance in the case of for-in enumeration. And we also now have object.keys, which makes for-in completely unnecessary, where we can just get an array of keys and use the array methods for dealing with those. I'm now going to talk about the most important new feature in ES5. That's the strict mode. Strict mode is different from all of the other stuff I've talked about because we're now talking about removing things from the language, not adding things to the language. JavaScript is a language which famously has a lot of bad parts, and we are limited in our ability to remove the bad parts from the language. But by having a strict mode, that means that you are opting in, that you want the improved language which is obtained by removing those bad parts. So the way you specify strict mode is with a pragma. The pragma is expressed as a useless string expression literal, which is either the first line of a file or the first line of a function. We chose this kind of odd-looking form because this is not a syntax error on ES3. So that means you can now write ES5 strict programs, and you can, if you're writing in that intersection, they can run without modification on ES3. So that's another technique for allowing us to interoperate with the obsolete browsers. So there are two forms of it. There's the file form and there's the function form. The file form means that useStrict is the first statement in the file, and function form means it's the first statement of a function. I highly recommend using the function form and not the file form. And the reason for that is basically Steve Souders. It's because of Steve Souders that you shouldn't use the file form. Steve still here? Yeah, it's your fault. So why am I pointing at that man and saying it's his fault? So Steve Souders observed that web browsers are incompetent in the way that they deal with script files. They get very pessimistic and tend to block, which slows down page loading, which deeply interferes with the user experience and costs everybody time and money, and that's a bad thing. So what's the solution to that problem? Well, we could go to W3C and insist that they fix the standards so that this kind of crappy behavior not be tolerated. But making stuff good is not what W3C does, so that was not an option. So instead, Steve decided to fix it himself by proposing some rules. And rule number one is reduce your number of HTTP requests. And the way you do that with script files is you take all of your script files and you concatenate them together into one big file. And it works. If you follow Steve's plan and follow rule one and the other rules, you can significantly improve the time that it takes to start your page, and that's a very, very good thing. So mission accomplished, case closed, done. The problem is you now have things which used to be separate and modular all mushed together. And in the case of the useStrict pragma, it means that the first file in the stream of files decides the strict mode for everything that follows. So if the first file has strict mode in it, then all the files that follow will have to be strict. And if they were not designed to be strict, they will fail, and we've already seen sites experience this problem. Or it could be the other way. The first file is not strict. That means strict mode does not get turned on for anything else. That's another source of problems. You know, it would have been better to fix the browsers. I think it is still better to fix the browsers, but that doesn't seem likely. So for that reason, I recommend you use the function form, because in the function form, the useStrict pragma is scoped to that function. So everything inside of that function will be strict, including its inner functions, but nothing outside of it will be strict. And that way we can concatenate files together and we won't have these problems. One of the things that happens with strict mode is that there are new reserved words. So you cannot name variables with these words. And that's because future editions may require these words. Not guaranteed that they will, but they might. Strict mode has a lot more rules and restrictions on the way it executes code. And these are important, so I'm afraid I have to read through this list. There are going to be no more implied global variables within functions. You'll get errors on those now. Yeah, you don't have to save your applause to the end. You can clap spontaneously. When you call a function as a function, this will no longer be bound to the global object. This will be undefined instead, which is better. Apply and call do not default to the global object or try to wrap this parameter in an object wrapper. You just get the value that you passed. No more with statement. In the future, there will be no with statement in JavaScript. If you try to set a property that has been set to not writable, you will throw. In ES3, you get a silent error, which is the worst kind of error. Death before confusion is my motto. And so, at least in this case, the program's not going to be confused by thinking that it set a value and keep running having not set that value. And a similar thing happens if you try to delete a property that is not configurable. There are restrictions on eval now. So eval does not get access to the function's context. So you cannot create variables. You can't violate the security of the function that called eval. That's great. Eval and arguments now act as reserved words, so you can't have variables with those names. Arguments is no longer linked with the parameters. I don't know if you're aware of this, but if you change one of the arguments that you were passed, a similar change happens in the arguments array. And if you take the arguments array and shift it, all of your parameters will shift. It's insane. It really is goofy. And it's also one of the things that makes JavaScript really hard to accelerate. So by having this restriction in strict mode, not only do arguments get a lot more rational, but it'll be easier for the JavaScript engines to go fast. There's no more arguments.caller or arguments.callee. This was a bit tricky to specify because the standard never had arguments.caller. So we couldn't delete it from the standard because that wouldn't have any effect. So what the standard does now is it says the implementation in strict mode has to set them to null. So that was weird. No more octoliterals. We haven't needed octoliterals since Fortran, and somehow they keep finding their way into modern programming languages. We're trying to stamp them out. So in strict mode, octoliterals go away. And it's now a syntax error for an object literal or function parameters to be duplicated. This should have always been the case, and now it is. Let's see, some good things come from these rules. One is that forgetting to use the new prefix will now throw an exception rather than silently clobber the global object. So that's good. Again, death before confusion. We should be putting this on T-shirts and writing it on the walls. It should be our new slogan. So strict mode will break things. So you have to be careful when you opt into it because not everything is guaranteed to work. In fact, some things are guaranteed to break. And that's by design. That's what strict mode is supposed to do. So one case to watch out for is calling add event listener as a function is probably going to fail from now on. And the reason is when you call something as, in the old days, when you called something as a function, this would be set to the global object. And so add event listener would happen to get window, which is the browser's name for the global object. That doesn't happen anymore. On ES5 strict, this will be set to undefined. And so add event listener tries to add an event to undefined and will fail. The correct way to write it, and this works in ES3 too, so there's not a compatibility problem necessarily, is to put the window.prefix on it. Now it's being called as a method. Now this will be bound to the global object and it will work. There are a lot of those, but this is probably the first one you're going to run into. There are no methods in strict mode for determining if you're actually in strict mode or if it's possible to go into strict mode. But fortunately, it's really easy to figure out. So in strict mode, simply calls a function immediately and looks at what this was. It negates it. So if it was the global object, it turns into false. And if it was undefined, it'll turn into true. And then if you want to find out if strict mode is possible in your system, you do the same thing, except you make the function that you're calling be strict. And so it'll then follow the right rules if it knows how. If you're on a system that doesn't know about strict mode, then the use strict pragma is ignored and the program keeps going. So if you're using JSLint, chances are you're going to have a really good time converting to strict mode. You still need to test, obviously, in strict mode browsers, and that's becoming possible now. There's some stuff that JSLint will not find because JSLint does a static analysis and much of the new strict mode rules are dynamic. So there are things that JSLint can't find, but it can find a lot of the problems for you. So why do we care about strict mode? It's because of mashups. Mashups are an important mode of software development. It's something that people have been working on for decades, and it sort of happened in JavaScript with virtually no effort. Just that JavaScript happens to have this amazing set of properties that made it easy to do mashups, whereas in other languages it was still an unsolved problem. Mashups are really important, but we have the problem that the security model in the browser did not anticipate mashups. And so it's not possible for a page to defend itself against the third-party scripts that are running inside of it. So the way that we've been dealing with that at Yahoo is with safe JavaScript subsets, where we try to constrain the power that the third-party code will have so that it cannot take over the page or corrupt the user or do any of those things. And there are lots of versions of this idea. The one that we use at Yahoo is Kaha, and there's also my own development, AdSafe. Kaha and AdSafe are based on the same theory, but took completely different approaches to how they implemented it. Kaha does a JavaScript to JavaScript translation. And in that process, it adds a lot of runtime checking and redundancy and indirection to the program in order to allow it to have confidence that the program cannot get out of control when it's executed. One difficulty with that approach is it adds complexity to the development process because the code that you're debugging may not look anything like the code that you wrote. And it can also slow the script down pretty significantly, which hurts performance, and we're trying hard to make things go faster, not slower. AdSafe takes a different approach. It uses static validation. So it looks at a program, and as long as it can determine statically that it doesn't use global variables and doesn't use facilities in the language which would allow it to get access to global variables, then it's safe. So AdSafe has no translation and no runtime penalty, which is great, but it uses a greatly restricted subset of the language. This is not allowed, and the subscript operator for all purposes is not allowed either. It turns out you can still write good programs in the subset that's left because function is in that subset and you can do great things with function, but it's more difficult to use. So with strict mode, with ES5 strict, we can get the benefit of both. We can get the larger language that we get with Kaha with none of the runtime penalties because we can do everything with static validation. That ES5 strict gives us enough control over the browser's environment that we can statically determine that a program is going to be safe. So with a little bit of library assistance, we can have third-party code running in the browser in a fully cooperative mode without any degradation. That's a great thing. That's why this is so powerful, because security is the biggest problem that we have in web applications. But then there's the IE6 problem. Again, you don't have to hold your applause to the end if you don't want to. So IE6 used to be the best web browser in the world, was for many years, but it's not anymore. It's way past its expiration date, but it's still one of the most popular web browsers in the world. Its numbers that we see are still consistently bigger than Opera, Safari, and Chrome combined. So it's hard to ignore this monster. But it's way out of date. It does not run ES5. You get none of the benefit of ES5 until we kill this thing. So that's a problem. That's a big problem. And i7? Yeah. 8. Now this one breaks my heart. 9. I'm really unhappy to report this. So I'm impressed with the things that the IE team at Microsoft has done with IE9. I thought they were wedged. I did not think it was possible anymore for them to make a good browser, that just with all the legacy problems they've got and everything. But they've done some really good stuff in IE9. But they made one really huge blunder. Somebody at Microsoft decided that it was not important to implement strict mode. I think they did a survey of some developers and asked them, do you need strict mode? And they made it a point to ask developers who didn't know what it was. And they said, no, I guess not. So they went, good, so we don't have to do it. Now it turns out the standard has no provision for subsetting in it. So you're either standards compliant or you're not. And Microsoft chose to be non-compliant. And the reason they give for that now was they just didn't have time, or they were short-staffed. They couldn't find somebody to do it. I think Microsoft employs more programmers than any other organization in the world. They couldn't find somebody to implement strict mode. That's what they say. They were not blindsided by strict mode. Microsoft was on the committee that created this. Microsoft's representative was one of the principal architects of strict mode. He was the editor of the standard, did a brilliant job of the standard. It's the best web standard in the history of the web. Microsoft voted yes at the General Assembly for this. So it's not like they didn't see this coming. The IE team didn't see it coming. The IE team didn't understand the importance of JavaScript to the browser. And the reason for that is it's an organizational problem at Microsoft. The JavaScript team is over here with dev tools, and I think Windows is over here with operating systems. To find the lowest common manager, Steve Ballmer, okay? So the IE team didn't know this was important, didn't know to ask the tools team, we need this, get it done. And once they realized the blunder, they just dug in and said, well, we'll just tell people we didn't have time to do it right. And so IE9 is shipping without strict mode in it, which means that we really don't get the benefit of strict mode until IE9 is dead. And I hate that. I think Microsoft has done a terrible thing to the web community in doing this. Will they get it right in IE10? I don't know. They have not announced IE10 yet, so we don't know what's in it. I'm hoping that they're paying attention and they'll get this right. So this is a big disappointment. So what's next? So that's ES5. It took about an hour to describe everything in it. Not a lot there, but it's good stuff. Gives you much more control over the language. I don't expect everybody's going to use the Meta Object API in their applications. In fact, I think you shouldn't, but it makes a lot of sense for the libraries to use, because they can now make better objects. So what's in the next edition? Don't know at this point. The committee is still trying to work that out. There's some things which look likely, but could change. So don't start coding to any of this, but this is some of the stuff that I think we might see. I think we may see lighter and more expressive syntax. We might see comprehensions. I think we might see that those stupid parentheses that are around the if statement, turns out there's no need for those. You've got if on one side and the curly brace on the other. That's a Fortran thing. We don't need that. So maybe those go away. So the language might get lighter. Maybe we'll come up with a better alternative to semicolon insertion. That would be nice. We'll probably see more expressive literals. So the stuff that I showed you that you could do with the Meta Object API, it's possible that you might, in the future, be able to do those directly in object literals, that annotations will be there so you can do it more easily. A feature that I'm very much looking forward to is proper tail calls, tail recursion, which means that when the last thing that a function does is return the value obtained from calling another function, that when we generate code for that, instead of doing a call and a return, we can just do a jump. And that can give us enormous performance benefits, and even more importantly, it opens up whole new forms of programming. We can do continuation passing style programming. We can do monads and arrows and all these wonderful new functional construction things. This is going to push the language to a really interesting new place. I'm very much looking forward to that. We'll probably have modules. Modules, I think, will be the most important feature of the next edition. We'll finally get rid of the shared global object, which is the source of the cross-site scripting problem, and finally have good interfaces in the language so that you can define a module and it can declare its interfaces and decide for itself how much of its guts it wants to expose to the rest of the community. That'll be a really good thing. That'll go a long way to fixing our security problems. We'll have proxies in the language. Proxies are like catch-alls. They allow you to muck with the inner wiring of objects and control their behavior at a level that's way more intricate than you can do now. It's like getters and setters, except 1,000 times worse. You can really do terrible, ugly stuff with proxies. Now, the benefit of proxies is that they will allow us to fix the DOM, that we can put a proxy perimeter around the DOM so that we can control the security of the DOM without having to re-implement the whole thing, which is the way we have to do it now, and that's really expensive. A better way of fixing the DOM would be to have W3 fix the DOM, but that's not going to happen. So at least the ECMAScript committee is on the right page with respect to this stuff and is dealing with the important problems first. So proxies, in my view, is not an ideal solution, but at least it's a solution, and that's better than what we're getting. We might get around to fixing the type of operator, so that type of null will be null. Would anybody like that? Yeah. And much, much more. Probably way too much more. Committees love putting new stuff in. This is already, I think, a really long list, and it goes on way, way, way longer than this. So I'm hoping that the committee can find the will to keep it small. The difficulty in doing that is all of the features that we're considering are really interesting and probably valuable, but the sum of all of those features, I think, is going to be excessive. And so we're going to have to make some hard trade-offs in deciding what to put in and what not. So that's all I've got for you tonight. I'll look for you next time when we get to Section 8. Thank you and good night.